All right, so I just wanted to make a quick video of trying to kind of visualize what our polar graphs look like compared to what our normal rectangular graphs look like. Now, when I look at this one on the left, what I graphed really was, um, y equals 3 times the sine of theta. If this is our theta axis, we're still going to think of this as our theta axis. If this is like our y-axis, that's on our normal, rectangular coordinate plane and everything. But really, if I think about it, if I'm thinking r equals 3 sine theta, instead of calling this y, I'm going to call that r. But keep in mind that our points are r comma theta, not like an XY on there. So just to kind of sort of visualize what's actually happening on our polar graph here. So again, the key thing with R is that it's the distance away from that pole, and that pole is like kind of that origin, that center in the middle. So if I look at the graph, I just wanted to kind of show that kind of general idea. If I look at this first part here, again, for r equals, 0, we are at theta is 0. So the first point is on the pole at 0, going in the right-hand direction here along, this axis over here. It is just going through 0 here. But then if I kind of trace along this here, I'm getting to this top at pi over 2, we have an r value of 3. So what that's really doing is, again, this as getting further and further, that r value is getting bigger and bigger as we are approaching that pi over 2. And really what that means is that we are getting further and further away from the pole. So, here it's not that far away from the pole. Then as we get over to pi over 3, it's a little bit further away from the pole. And then up at pi over 2, that's the distance that's furthest away from the pole. If we look really at pi over 6, we can see on our rectangular graph, we have a point at pi over 6 and 1.5. Again, if I look along my pi over 6, notice we do have a point here at 1.5 as well. Just to, again, kind of think about what's happening. If I, go now from pi over 2 back down to pi, again, what's happening is it's getting closer and closer to 0, so that r value is getting smaller and smaller. So if I'm up here at pi over 2 and 3, again, here as we make our way over to 2 pi over 3, again at 2 pi over 3, that r value, it's not quite as, far away from the pole as it was at 3 there. Again, we're going to keep making our way around. As I go to 5 pi over 6, notice that that value is 1.5, and it is over here as well. And again, it comes right back down to 0. So at pi, again, here it was over here at pi, we are back at 0. Now you'll notice we're at the negatives. If I think about the negatives here, again, that distance away is all still the same. Like our distance from here at pi over 6 to 1.5, that's that same distance right here. At pi over 3 and 4 pi over 3, again, those distances away are exactly the same. When we're thinking in terms of r, that's just changing the direction. So if I am, again, here I'm at pi at 0, and if I'm over here at like 7 pi over 6, again, instead of being at positive 1.5, we're going in that negative direction. So all the way along these angles over here, we're going to be in the negative direction, and you'll notice that really that just traces over the same thing that we already had. And then if I think about, coming back to 2 pi, again, that's all of these values along here from 3 pi over 2 to 2 pi. Again, our values are all still negative, but they are getting closer and closer to 0. So again, that's all along here, but when we're in the negative direction, that's why it puts it up over here, and it's going to get closer and closer to that pole. It's just really going to repeat it. So that's why, again, kind of one of the reasons why it's a little bit more easy to visualize this as a circle there. All right, let's look at this one here. This one is one of our limacons here. And again, this one's a little bit more complicated to think. So if I look along the first part, you'll notice here that at 0, I'm starting at 3. So this is really where our graph is starting, where our, again, theta value, these are our theta values. I'm thinking these are the r values. It's starting here at 3. So if I follow along my graph to where it reaches its maximum point here. Again, the R value is increasing along there, so it's getting further away from the pole. So as I'm going along here, that's really this part at pi over 2. It's up here at 9. So now if I look at it, and I can, again, keep going, if I go down to right here and just kind of visualize that part, again, that's at pi. We are up here at 3. So the R value is getting smaller. We're getting closer and closer to the pole. That ends up at this spot right here. So now this is kind of a unique little part right here, from pi to 7 pi over 6 right here. So at pi, we're here at 3, and at 7 pi over 6, that's where the R value is 0. So that means that's where it's going to intersect the pole. You'll notice that the R values along this purple part right here are all still positive. So along, these angles here from pi to 7 pi over 6, it's still positive. Now they're getting smaller and smaller, so that means it's getting closer and closer to the pole, and then it really intersects the pole right at 7 pi over 6. Then, let me switch colors here. If I go from 7 pi over 6 to 3 pi over 2, again, right here, again, it started at the pole at 0. And then at 3 pi over 2, you'll notice, so 3 pi over 2, it's negative 3. So that really corresponds to this point here. Again, the R value is negative, but that really just means that it's getting further and further away from the pole. So that means that's this little part of the loop in blue here. And let's pick a different color. We'll go green. So from that furthest point up to 11 pi over 6, that is going to be the finished part of the loop. And again, we'd go back through the pole right here. And then finally, right here at 11 pi over 6 to 2 pi, that brings us back, again, that's back at positive. So from 11 pi over 6 to 2 pi, this little, these little parts right here, that's why it ends up being, again, I know it looks weird because it looks, we're thinking like the y coordinate looks negative, but it's not a y coordinate here. At 11 pi over 6, again, it's 0, but here those values are still all going to be positive, and it brings us back there. So you can kind of look at the corresponding colors to see which part of the graph corresponds to which part. So let's look at another one here. So that was, the limacon with the inner loop. This one here, let's take a look at what this one, notice is a cardioid here. So thinking of where our graph starts over here on the rectangular, again, I'm thinking this is r and this is theta, so not like an x and y coordinate here, but it starts at where r is 3 and theta is 0. So it actually starts at the graph right here, and then it gets further and further away from the pole till we hit pi over 2. So it's getting further away from the pole and hitting right up here. So that's this part in pink that it corresponds to. So then, again, right here at that pi over 2, it comes back down to pi. So this little part in green, again, we still have a positive R value, but the R value is getting smaller. So I'm going around here and coming back down to where that R is 3. Again, along at pi, this is pi right here, that is a positive 3 value here. So if I look at the next little part, from pi to 3 pi over 2, the R value is still positive, but it's decreasing along the way there. So that means it's just getting closer to the pole. And then at 3 pi over 2, it's going to be 0. So that comes in and touches and intersects with the pole. But again, from, pi to 3 pi over 2, all the way along here, those values are still positive. It's still on this, positive side of our polar graph right here. And then we'll pick one more color here. Going from 3 pi over 2 back to 2 pi. Again, R is still positive among this entire graph right here. And it's not true for every cardioid along the way here, but for this particular one. So it starts at that pole, and again, all of those values are positive. It corresponds to that little part right there. So this one, again, our cardioid. Taking a look at this last one, this is one of our dimpled limacons here. So if I go along this one, Again, looking at our first part, it starts at 3 here, and then going up to pi over 2, looking along here, that's this little part of our circle along the way here. You notice a lot of those are kind of similar. I picked signs for all of these here. Then we're going from, where am I going here, to pi, pi over 2 down here to pi. Again, that brings us right down here. Okay, and again, you'll notice for this particular graph, none of these values, none of the R values end up being negative here, and none of them actually intersect with the 0, so none of them will intersect that pole. So at pi, it's 3, but then at 3 pi over 2, we're only here at 1. So that goes along this little part here. But again, you'll notice that it starts to curve up. So that's why right here it does go in just that little bit right there and starts to curve up. And then for our last part, 3 pi over 2 to 2 pi here. Again, all those R values are still positive. Here the R value is starting to increase and go further away from the pole. So it starts here at 1, and then the R values get bigger and bigger till it gets back out to 3 there. All right, so now to the ones that are our roses here. These are where it kind of, I think, starts to get a little bit more interesting here. Okay, so this graph starts at 0, 0. So it starts at the pole on our, 0 is, this is our theta, this is our R. So it starts at the pole here. And then it increases right here. And it increases, and I don't have it labeled here, but if this is pi over 2, that means this is pi over 4 right here. So it increases to that pi over 4 value on this one. So that is this part. It's getting further away from the pole. And then if I come back down right here from pi over 4 to pi over 2, again, that R value, it's still positive along this part right here, but it's getting closer and closer to the pole till it goes back down to 0. Then now notice that the R value is negative. So this is pi over 4, pi over 2, this is 3 pi over 4 here. So this is where it's kind of interesting here. So I'm at the pole right here, but I am going from pi over 2 to 3 pi over 4. So really thinking this is, again, 3 pi over 4 right here, but this is where it's negative along the way here. So if I'm looking at this pi over 2 to 3 pi over 4, we have to think a little bit carefully on this one. This one now, because I am here, so say I'm at this 2 pi over 3, were, I don't know, like but negative 2 point something here. If I'm here at 2.3 and I'm going to like negative 2 point something, that actually corresponds to this point right here. So if you think about it, this part in pink right here is actually this part of our graph here, because that is corresponding to the pi over 2 to the 3 pi over 4. So now if I go from 3 pi over 4 up here to pi, that actually, again, this is the 3 pi over 4 over to pi if I'm thinking about the actual angle values. Again, it's all negative. That's actually corresponding to this part. And again, so it goes through the pole again. So it started off, at the pole, went out, then it came back down, intersected the pole right at pi over 2. Then again, in the pink right here, it goes back out. In green, comes back and intersects the pole once again. And so now we're back where our value is positive here. Okay, so that means this point right here is our 5 pi over 4. So we are back once again positive. So we're at the pole and going from pi over to that 5 pi over 4 right here. That's positive, so that's going along this part right here. And then we're coming back around. This part in yellow goes back to the pole right here. And then once again, we are back in some negatives. So we got to think kind of carefully. If I'm at 3 pi over 2, and then this is 7 pi over 4. So we got to think kind of carefully here. Here's 3 pi over 2, and then here is the 7 pi over 4. It is going to bring us out to the negative over in this direction, but we have to be kind of careful right here. So if I'm at 5 pi over 3, again, we're about negative 2 point something there. So 5 pi over 3, the negative 2 point something, corresponds to this part. So this little part of the petal corresponds to the orange right there. And then we'll pick one more color here, going back up, not a great color, to 2 pi, finishes that petal, and we end back up at the pole there. Okay, so doing our final one here, looking at our last rose. Again, this one is unique because it only has the 3 petals, where this one ended up having 4 petals. Remember, when it's an even number for that A value, or I'm sorry, for the B value, I should say right there, we actually have twice as many. Whereas if it's an odd number, we actually just have that number. So let's look at it. I'm starting at 0, pi over 6. It's going 3, going all the way out to 3. So at pi over 6, it's coming out here. Again, the R value is positive and increasing there. If I'm coming back to the pi over 3, it's going back to the pole here. And now again, notice I'm negative. So pi over 3 to pi over 2, we're negative. So right along this part of our angles, we're negative. So if we look again very carefully, at pi over 2, we know it's negative, what is that, 3 on this particular one right here. And we have to kind of think, you know, again, a little bit carefully here. It's going along the negatives here. So if it's, you know, positive here, that actually corresponds to this part right here. Then still going along, here we're up to 2 pi over 3. That's again going back. So again, it's negative. So from pi over 2 to 2 pi over 3, it's negative. That's going to correspond to this kind of peachy area right here. Then 2 pi over 3 to 5 pi over 6. Going along here, we're back positive. So it's going to correspond to this. And then I'll do one more color. I haven't used this light blue. Going to pi, again, it's coming back around here. Now, if we look at this, you'll see that it's just going to start repeating that exact same thing, but with all the negatives along the way here. So I'll kind of just follow along. So if we look at it here, this from pi to 7 pi over 6, if I'm looking along there, so we're at pi, it's at 0. 7 pi over 6 is along here, but again, it's negative. That once again is going to correspond to that blue. So then if I think right here, 7 pi over 6 to 4 pi over 3, again, that's going to correspond to the negative. That's coming back down to the pole. Then 4 pi over 3 to 3 pi over 2. So we're over right in here. Again, if we think about it, that is now positive. That's going to be these values that correspond right to it. And this corresponds to that kind of peachy color going back around. And then we got another one that corresponds to that purple. Again, that's now negative, so it's on that opposite side. I'm going from 5 pi over 3 to 11 pi over 6 in that negative direction. And then finally, we come back up and finish it right here. So again, you don't have to necessarily do it this way. I don't want you to create the rectangular graph and go back and forth, but I thought it might provide just that little extra visual of where some of those numbers are coming from.